Good morning, everyone, and welcome to our Food Industry Development webinar series. My name is Ciara McDonagh, and I am Head of Food Industry Development here in Teagasc. This webinar series is delivered fortnightly on Tuesday mornings at 9:30 a.m. And over the coming months, we will be bringing to you a range of topics of general interest to the food sector, highlighting the expertise and services we can offer to Irish food companies. Today's webinar will provide an overview of cleaning and hygiene for food SMEs. Our speaker today is Eddie O'Neill. Eddie is a product development and packaging specialist here in Teagasc. He has also worked with small and medium-sized companies across the country on their cleaning and hygiene protocols. This webinar will involve approximately a half-hour presentation, followed by a short question and answer session. At the bottom of your screen, you will find a Q&A box where you can enter any questions that come to mind as Eddie is speaking, and I'd encourage you to enter them here. I will be monitoring this, and we will pose the questions to Eddie at the end of his presentation. If for any reason you experience technical difficulties or you lose contact during the session, please note that this webinar is being recorded and it will be available on the Teagasc YouTube channel afterwards. Finally, I would like to thank you for your interest and your participation in this event, and I'd like to now hand you over to Eddie.
Thank you very much, Ciara. Good morning all from a very blustery Cork this morning. Firstly, let me say that cleaning and hygiene is about producing food and safe food in a quality manner. Those responsible for the management of cleaning and disinfection in food manufacturing facilities often do not fully understand the reasons for plant hygiene. Food premises need to be cleaned continually in order to eliminate the possibility of the growth or contamination by pathogenic, which are disease-causing, and spoilage microorganisms. In general, good housekeeping will help to maintain a clean and tidy workplace so that safe and wholesome food can be produced on a continuing basis. However, a clean premises requires a commitment to hygiene from all members of staff. It is therefore essential that all staff are made aware of how the cleaning program works and what each individual duties are. The visual appearance is very, very important. The visual appearance of a food factory is an indication of the standards within that factory. It has a strong impact on the perception of an auditor or visitors that can influence their opinions. And for this reason, visual cleanliness is as important as any HACCP plan. So why do we clean? Food residues provide an environment where microorganisms can grow and so therefore must be eliminated. And we do this to reduce the risk of food spoilage and food poisoning. We do it to allow for the disinfection of equipment and equipment surfaces, to reduce the risk of contamination by foreign matter, to provide a safe working environment for your staff, and to promote a good and well-run image to your customers. On the trade side, good wholesome products that keep well and are free from hazards are good for trade. Customers will buy again and again. However, the reverse is also true. If the product is contaminated, then this can be very, very damaging to the company. The potential effects of poor cleaning and poor standards must be kept in mind at all times. And then there's an element of trust. Customers never see the factory or they see how the product is produced and handled. They take the company on its reputation and they trust that that company will produce food to the highest standards and in the cleanest conditions by well-trained staff. On the legal side, it's the responsibility of the food business operator to ensure the product is manufactured and packed in accordance with guidelines. Failure to meet these obligations can prove very costly. Prevention is always better than cure. Instructing people is never simply enough. In order to maintain high standards within the factory, within the plant, they must understand the reasons why cleaning is important. And it's often seen as a necessary evil. And why? Because it costs money. The cost of cleaning or the cost of not cleaning are seldom measured by food companies. Typical elements include labour, which is the biggest factor, accounting for 60% of the cost. And it can be easy to cut back on labour, but over time, this will lead to indirect costs, including a reduction in shelf life, and possibly even a product recall, which nobody wants. Next comes water and chemicals, and these can vary on usage and suppliers. And finally, let us not forget downtime. We see downtime because it's visual. Plant is not in operation, it's not packing product, it's not producing for us. But we don't see the value that without this downtime, we can run into serious problems. And there are some additional issues and reasons for cleaning. We reduce the risk of food safety hazards, including allergen cross-contamination and foreign body contamination. We do it to meet specific customer requirements. It could be from Tesco's, from SuperValu, whatever. We help to maintain and extend product shelf life and to ensure safe working conditions for staff. When we look at cleaning, there are three different types. There's the physical, visual clean, where the plant and equipment is cleaned to an agreed standard and all visible debris or soil is removed. Then we have chemical cleaning, where debris such as oil, fats, have been chemically removed from contact surfaces by the use of detergent. And then we have microbiological cleaning, where the food contact surfaces have been chemically cleaned and disinfected then to reduce the possibility of contamination by microorganisms. If we look at the nature of soiling and what's involved, on the organic side, we have fat, protein, starch, cooked or hard deposits. Excuse me. On the inorganic side, we have calcium, phosphates, limescale. And then we have biofilms, which we will talk about a little later in the presentation. Excuse me. Fats can vary from liquid to solid, such as cream, vegetable oil, or meat residues. They're insoluble in water. On exposure to air, they can oxidize, and this is why we try to clean as we go and minimize contact with the air. Exposure to high temperatures causes them to carbonize or to burn on, and this makes them even more difficult to remove. For instance, if you're cooking at home and you overheat your saucepan, as we've all done, you'll get burn on, and you know how difficult this is to remove. Fatty deposits are recognized by their greasy feel and water repellent properties. On the protein side, these are large complex molecules susceptible to denaturation. And under excessive heat, this denaturation can take place and makes them difficult to remove from the work surfaces. If you drive a car on a sunny day, as we have one or two this year, I suppose, you will end up with lots of insects hitting your car. And after drying, they're very, very difficult to remove. Why? Because they're composed of fat and protein. And you should bear this in mind when it comes to cleaning. And proteins are also very, very important because almost all allergens are made up of proteins and the other normal constituents of foods. Allergens is not another form of food poisoning caused by contamination, but they shouldn't be in food. Allergens cannot be eliminated by baking or cooking, but there are also intolerance reactions, such as consumption of lactose, histamines. And allergens should be controlled based on sound HACCP principles within your factory. Starches then are the final category. They vary from product to product, but they are usually of plant origins, such as corn flour. We're all familiar with that in the kitchen. Then there's maize starch, potato starch, and a range of rice starches. They're commonly used as thickeners in the food industry and are made up of long chains of sugar molecules. Again, very difficult to remove, and especially if overheating is a problem. We move on then finally to yeast and molds. They are commonplace in Ireland because of our cool, damp climate. They can be found as black or green spots near freezers or chiller units. And I'm sure most of us, if we looked in our fridges at some stage, we see little black dots if we haven't cleaned regularly. These are generally actually not black, but dark green and classed as cladosporia, beautiful little fellas under a microscope. Yeast and molds are mostly associated with food spoilage, where they grow on the surface, resulting in unsightly colonies. And how do we remove them? We remove them by using detergents. And there are different types of detergents. If we look at organic soil, fat and grease, we remove that using an alkaline detergent. Protein, we use a chlorinated alkaline detergent because it's more powerful. And on the starch side, again, an alkaline detergent. And a detergent is a cleaning agent that includes surfactants or wetting agents as part of its formulation. Detergents can be alkaline, they can be acidic or neutral. But before making a decision, it's important to identify what type of soil you are dealing with. On the organic side, we have fats, proteins, starches, as we've mentioned previously, and even combinations of these. They may take the form of simple raw soiling or debris, such as milk, or more complex compounds, such as cooked or burnt-on deposits. And the detergent for this is usually, as I said, an alkaline or a caustic soda-based one. They usually have a pH somewhere between 8 and 14. Combination of chemicals, including sodium potassium hydroxides with surfactants added. The blends of chemicals are usually much, much better than individual chemicals themselves, but they're also more expensive. I mentioned as well chlorinated alkali for the removal of proteins. And this is an alkaline compound to which chlorine has been added to improve the protein removal properties. And residual chlorine will also have a disinfectant effect as well. Surfactants such as Twi-90 and Triton-X, they are hydrophilic, which is water-loving, or hydrophobic, water-hating. And they are surface active agents. They generally take the form of anionic, which are the most common used, which have negatively charged particles at the end, and cationic, which have stronger charged particles. They are stronger than uncharged detergents. They help to bind to protein molecules, altering the charge and helping us to remove them. And the electrical charge on your surfactant, be it negative or positive, determines on what type of surfactant that is. On the inorganic soil, we're generally talking about limescale, calcium, phosphorus deposits. And to remove these, we need an acid cleaning agent. Excuse me. An acid detergent has a pH of between 0 and 6. And they may have chelating agents added. They're very effective at removing scale. But they also have an inhibitory effect on many microorganisms, such as thermodurics. And thermodurics have the ability to survive pasteurization by producing a spore. And one of the few methods of ensuring their destruction is the use of an acid detergent. But they should be prevented from coming into contact with chlorinated alkali compounds because it may result in the liberation of dangerous chlorine gas. In fact, acid and alkaline chemicals should always be stored separately. We mentioned chelating compounds, and it comes from the Greek meaning claw. And they grab onto positively charged metal ions and they keep them into suspension. These help in the removing of inorganic salts and also prevent hard water scale during cleaning. Products such as EDTA are added in small quantities to acid detergents to improve cleaning and prevent scale deposits. We mentioned biofilms previously. Some microorganisms, such as Pseudomonas, while they're not pathogenic themselves, they do produce polysaccharides, which are long chains of sugars. And they have the ability, these polysaccharides, to combine with salts, producing biofilms. They're unseen to the naked eye, and in hard to reach places such as under shelving, on steps, and on drains, that's where they can be found. They are tenacious and very, very difficult to remove. So it's very, very important that when you're cleaning, you must be certain that your cleaning schedule is capable of preventing biofilm formation. And we can see from our slide that with very, very little infection at the start, they're surrounded by these polysaccharides combining with salts. The bacteria grow inside until they get to large numbers, and then they break out. And this can sometimes explain in food premises where you have hit and miss peaks and troughs of unwanted microbiological counts, often down to biofilm formation. And how do we kill our microorganisms? Well, we look at disinfectants and sanitizers, and there's often confusion here. A sanitizer usually refers to a product containing both a detergent and a disinfectant, whereas a disinfectant is a product which kills microbes without the use of a soil remover or detergent, such as QATs, quaternary ammonium compounds, or peracetic acid. They should only be used after an adequate cleaning with a suitable detergent. They will only be effective if they are in direct contact with the microorganism themselves. And in addition to chemicals, heat can also be used as a disinfectant. Hot water in excess of 80 degrees centigrade, circulated in CIP or cleaning in place pipework, is commonly used. Dry heat in excess of 100 degrees is commonly used to disinfect glass jars prior to filling. You should note that disinfectants should be active at low temperatures. They should be non-tainting and non-toxic, preferably biodegradable, and above all, cost-effective. And disinfectants take many forms. Halogens in the form of chlorine and iodine, such as hypochlorite and iodophors, are commonly used, with the hypochlorite in widespread use. Chlorine is effective against all microorganisms, including spores. However, it's inactivated by organic soiling. It has limited stability in solution and may cause corrosion if used in high concentrations over time or allowed to dry on contact surfaces. They are commonly used in soak baths, where you have a higher concentration of your disinfectant because you have no mechanical action, where parts are removed and stored overnight. Then we have ORCs, or oxygen releasing compound. And a clear example of one of those, and quite commonly used now, is peracetic acid, which is a combination of hydrogen peroxide and acetic acid. It's a potent disinfectant, even at low concentrations and low temperatures. It's non-tainting, non-toxic. It does have a pungent odor. It can be used primarily in CIP systems, but we also use it as a spray for contact surfaces and so forth. And in our experience to date in Moore Park, we have found it has an excellent bactericidal effect on listeria. We move on then to QATs, or quaternary ammonium compounds, and these are the most common disinfectants used in Ireland today, even though they don't have a wonderful killing rate when it comes to yeast, molds, and spores. Along with this, they tend to be less favoured in the dairy industry, as in excess they can have an inhibitory effect on starter cultures, but they do have high foaming qualities and are great for foaming within the plant. QACs are also used in fogging, which we'll talk about in a little while. But when it comes to actual cleaning itself then, we use a system called TACT, where we have time, action, concentration, and temperature. And when we look at time, there's two issues: not enough time given and you don't get surface interaction. Too much, the temperature may cool and your detergent may deposit. Get it right, follow the manufacturer's instructions, the surface wets, soils are removed and washed away. In terms of action, we're talking about mechanical force. And this takes two forms. It takes the form of foaming and it takes the form of turbulence inside in CIP. It loosens soils and the foaming is very, very good for disrupting biofilms. On the concentration side, generally these mistakes are made with not enough, too little, not enough cleaning power, but mostly actually too much, where residues are left behind. It reduces efficiency, increases cost. Again, follow the manufacturer's instruction to do the job that's required. On the temperature side, use the correct temperature according to your SOPs and your cleaning supplier recommendations. Water should be at least 50 degrees centigrade. Too hot may cause proteins to denature, and they may deposit, which can be a hazard later on. And when it comes to cleaning, we have manual, foam cleaning, and fogging in general. But before that, we look at our cleaning steps, which are pre-rinsing to remove soil prior to cleaning. We wash then under tact, we post-rinse, and we sanitize. If you remember what I mentioned early on about your car covered in insects, well, if you bring your car to a cleaning, to a garage for cleaning, and you take out your lances, first of all, you apply a rinse, then followed by foaming, and again, that would only do so much. And then you take out your brush and you scrub incessantly to remove these difficult fats and proteins from insects. And when you've done that, you do a post-rinse. In the case of a car, you then wax. But in case of a food business, you actually sanitize using a detergent to reduce the number of microorganisms. So you do well to remember that analogy. And when it comes to cleaning, manual cleaning is about removable parts. They need a great degree of mechanical energy and detergent strength. Temperatures used are limited by associated risk to workers. Again, soak tanks are commonly used. I mentioned those already. Mechanical action in these are almost nil, but we use strong chemical concentrations. Foam cleaning is the most common method used in most food operations. A blanket of foam is used to coat the equipment, floors, walls, and is then rinsed off after 20 plus minutes of contact time. What's good about it is it has great mechanical action. But as well as that, you can clearly see where the lance has produced foam and has covered your wall, covered your equipment, and so forth. On the fogging side, aerial fogging uses compressed air to generate a fine mist that hangs in the air and penetrates every nook and cranny in the processing hall. It must be used in conjunction with other cleaning methods and not just on its own. When we look finally then, apart from manual foam cleaning and fogging, there's CIP or cleaning in place. And this is all about the interior cleaning of pipes. And you have a program cycle and you have a turbulent flow inside, usually about 1.5 to 2 meters per second. And this turbulence gives you mechanical action and helps you to remove any soiling that may be present. But then how do we validate everything? You must document the actual cleaning procedure. It must be clear and defined. You must have a clear cleaning schedule that anybody can follow, and whoever is involved in cleaning must sign off as the responsible person. You should have monitoring checks, be they visual or ATP. I tend to use ATP quite a lot. It's a very, very simple swab, either of the rinse water or of the pipe work itself. It goes into a very small machine, you press a button and you get a reading out. And once the reading is below a certain level, then it means that your detergent and your cleaning work has done a proper job. if your level is above usually 10, you haven't done a proper job and you may need to re-clean before you start food production. Again, this is all part of training your employees, and it's about retaining complete records and any comments that you may have in your day-to-day work within the factory environment. Color code your equipment. Very important to have your shadow boards, be they red, be they blue. There should be no crossover from high risk to low risk areas. Your brushes should always be stored off the ground, easy to see and easy to access. We are surrounded by COVID-19 at the moment. And one of the dangers is the use of quality staff where they're removed from their general day-to-day work within the plant to cover the COVID-19 rules and regulations. So we drag away Mary or John to check temperatures, to fill in forms, to check with clients who may be coming on site, to check deliveries and so forth. But we run the danger of taking our eye off the ball. Don't forget what has served us well in the past. It's up to us to ensure that our standards do not lapse. And again, be focused on what has served us well in the past, which is a clean and safe regime. Key points then are following. Clean as you go. Clean surfaces are necessary to ensure satisfactory disinfection. However, facilities and equipment must be adequate to do the job effectively. Efficacy of disinfectants depends on chemical composition, time and temperature. Remember tact that I mentioned. And each disinfectant has its own unique properties. Some people like the killing power of peracetic acid. Other people like to use quats and so forth. Again, try to look at the food product you're producing, tie the detergent in with that, and tie your disinfectant into your system as well. Protocols must be in place for all cleaning and disinfection activities. Chemicals used should be stored safely. I mentioned previously, use combined detergent sanitizers as opposed to separate chemicals. It will, in the long term, save time and money. Keep the number of chemicals to a minimum and to avoid confusion. Some companies use color-coded detergents, sanitizers, and disinfectants. And this makes it very, very easy for staff on the ground to use the blue as a degreaser or to use the yellow as something else. Never ever mix chemicals. They may become neutralized or at worst become toxic. And finally, we do a lot of work in Teagasc with Safe Food, which is the Food Safety Promotion Board. And they have produced a number of videos in conjunction with Moore Park Technology here in Fermoy and Cork. A number of videos on cleaning of equipment, hand washing, and these are very, very useful tools for staff. And I would recommend that you make a point of seeking out these videos and spending time to look at them as a training tool for your staff members on site. Thank you very much.
Thanks, Eddie. Really appreciate that whistle-stop tour of hygiene and cleaning. I encourage our audience, if they have any additional questions that they want to pose to Eddie at this point, if you just click on the Q&A box at the bottom of your screen, you can type them there and we'll monitor them as the conversation evolves. So as a starting point, Eddie, can I ask you, in your experience, what are the most common mistakes that companies make when it comes to cleaning?
I'm afraid to say it's cutting corners. Some people think that a clean down on a Friday or Saturday works for the entire week. It doesn't. And by adopting that approach, they're admitting that they don't understand the role of cleaning and the proper use of cleaning agents. Also, a lot of people, some people reduce the chemical use in order to save money. And, you know, you use chemicals at 0.75 or 1% or whatever the manufacturer recommends, and that's there for a reason. But generally speaking, cutting corners does exist, and it's a poor time practice, it's a poor money practice, and you can get yourself into trouble over time.
Thanks, Eddie. Some more specific questions here, and again, if people want to pose some questions to Eddie afterwards in terms of their specific products or factories, they are welcome to. But this is a question around struggling to remove salt deposits on the side of brine tanks. Would you have any advice to give there?
Actual manual cleaning. Salt patches dripping down brine tanks is simply just the brine overflowing. That's all it is. The water dries off and your salt and your calcium is left behind. Basically manual cleaning. That's the only answer. Some people can use power washers. I'm not mad about them. We've had experience of power washers in the past where they were responsible for contamination, where people were using power washers causing aerosols, and the aerosols were spreading to product within the next room, or sorry, at the end of the hall rather. Manual cleaning, it's simple as that. Just a bit of elbow grease, unfortunately.
Okay, and I'm not sure that this is the same answer. Have you any experience with pasteurizer plates oiling and how to remove that?
Pasteurizer plates, it depends, right? If you're manufacturing something like a yogurt, and one of your ingredients might be waxy maize starch, for instance, right, for the cheaper products, and that can burn on, and it can be quite difficult to remove. Again, talk to your company. I believe, really strongly believe in developing a very good relationship with your cleaning chemical company, be they the Healy Group or BioCell or whomever, okay? And if you develop a very good relationship there and express your concerns, you might need to up your detergent concentration from 0.75 to 1%, something like that. Okay? I don't believe in using excessive temperatures in cleaning, especially when it comes to acid cleaning. Excessive temperatures in excess of 60, 65 degrees can result in O-rings deteriorating, and you can find little black flecks in your product. In terms of pasteurizer plates, that's cleaned by CIP, cleaning in place, and it might need just an adjustment to your concentration of your detergent to help with that. But then consult with your, or you're welcome to email me privately to discuss it in more detail about what product is actually going through and so forth.
Okay, thanks, Eddie, and we'd offer that invite as well to anybody else who has a specific question. Another question here, Eddie, what is your view on dry cleaning when we're dealing with an ambient low-risk material like a dry powder?
Well, generally speaking, dry cleaning is perfect. It's used in the bakery industry all the time. So wet cleaning is not an option. And we use things like hoovers to hoover up dust. Dry cloths and something like that is quite common. Again, it's very specific to one type of business, but it's quite common, as I said, in the bakery industry, where water is not an option.
Thanks, Eddie. Query here, is a reader for ATP affordable for a small producer? Would you have any?
The cost, I'm not sure the exact cost, €2,000 to €3,000. You have to be a certain level before you can afford it. And yes, this is why it's absolutely critical to follow instructions when you're a very small company. If you follow instructions and you clean as per your SOPs, you shouldn't have an issue. Right? When you get to a certain size and you can afford an ATP machine, they are wonderful add-on checks, okay? Wonderful add-on checks. But that doesn't mean that you become careless with your detergent use and so forth. It's all about detecting organic matter. But if you have a good cleaning process in place, you don't need them as a small food company.
Okay. can I ask as well, are the ATP swabs suitable for production with high level of fat?
ATP swabs are suitable for any organic matter. Any organic matter, yeah.
Okay.
Again, high levels of fat, you need to look at your detergent, what temperature, fats are mobile above 45 degrees, but what temperature you're using, what concentration you're using, but above all, turbulence will help to remove high fat products.
Okay. There's another question here in relation to your own opinion on ozone sanitation. Is that?
Oh, it's all the news at the moment. Ozone is going to kill everything and so forth. I've only ever used ozone once, and that was in a university in America a number of years ago for bleaching wood pulp fibers, where I was producing fiber for a client, and I used ozone as a bleaching agent. I don't know enough about it, and I haven't used it in a food environment in terms of similar to fogging. I would need to know more about it and look it up. But at that time, ozone, we had an ozone generator, and ozone's a poison, so you want to be very, very careful at what levels it's used in terms of parts per million. I would need to know a bit more about it, and I don't know enough about it in terms of food use.
Yeah.
I have never personally used it.
And I suppose the application in terms of the facility, the type of food.
Yeah, exactly. You have to look at every little detail, as well as consulting with the company who is advertising it. And an awful lot of claims can be made. We've come across down through the years cleaning products that you rub them on your hand and you're guaranteed 24-hour protection. It turned out to be just pie in the sky. So again, while it's worth investigating, I would just tread carefully.
Make sure that the validation is there. And
that you can validate
your product and your systems. Because a general ozone sanitation is very different to how it will perform within your own.
It is very, very powerful. It's an oxidizing agent, very, very powerful. Just be careful.
And another question with regards to cleaning schedules, which you referenced. What's the key information that a food company should include in their cleaning schedule?
The cleaning schedule is about, remember I mentioned tact, it's about concentration and time. So if you have a CIP system and you press your button, you start it off, you need to check the concentration of chemical, be it through a titration or through conductivity. You need to be able to check your concentration of chemical. You need to be able to check the time of circulation at the cold end. And the cold end should be a minimum of 50 degrees before you start your time. Too many people press the button, look at the watch, we'll give it 15 minutes, grand. That's not cleaning. So you need to check your concentration of your detergent, either through conductivity or through titration, and then you need to give a proper amount of time to do its work. Okay?
And another question, so if we take this advice on board or use the guidelines and information that you've outlined today, how do we know that our cleaning has been effective? How as a food producer can we?
Well, the food producer, you're obliged to get each batch, depending on how big you are, tested for microbiological content and so forth. And that's a very, very good indicator. On occasion, we get queries in relation to yeast and mold. The levels have increased. We have problems with shelf life, colonies growing or blowing. Then we look at each company on an individual basis, and we can offer advice, look at their current cleaning schedule, and then offer advice in terms of how to tweak that to eliminate a problem that is coming about. And often these things are very hard to explain. Very, very seasonal. We tend to have problems at the end of the summer. In terms of August is generally warm, and we tend to have more problems at this time of the year than we would have in January, February. I would recommend that if you have issues, you're welcome to send me an email and we'll do our best to sort them out for you.
Great, thank you for that, Eddie. There's just a comment here from one of our participants today in relation to foaming equipment, and just a comment in relation to the actual quality of the foam, good maintenance in terms of preventing leaks,
Yep.
results in better safety and less cleanup. So I suppose that's something you would probably agree with. And
absolutely. It's about taking care of what you're using, day after day. Foaming equipment is the same as any piece of processing equipment. It needs care and maintenance. The pipework needs to be cared and maintenance. You don't wrap a piece of plastic tape if there's a leak somewhere. You replace your length of pipe and so forth. Your nozzles are very important. Nozzles are very, very important to ensure that they're clean and that they do exactly what it says in the tin, producing an even, proper foam.
Thanks, Eddie. Okay, can you advise on what the best detergent or disinfectant to use is?
Yeah. Different companies provide different services. I mentioned already, BioCell, some use Ecolab and so forth, right? It's important, as I said, to develop a good relationship with your cleaning chemical supplier. What you will find that a lot of companies are advertising very, very similar products, but often the products are tailored to the specific use. We would use Lactrin. It's commonly used in the dairy industry for CIP cleaning. Okay, so it's a detergent that's designed for a purpose. So what's very, very important is, rather than me saying and giving you names of detergents, right? On the disinfectant side, I have years of experience of working in the food sector, and I found that peracetic acid, in my opinion, is the best disinfectant that you can possibly use. It can be used at low temperatures, at very, very low rates. And it's fantastic. Now, I won't give you commercial names. It's called Serpent, it's called various other bits and bobs. But certainly, that for me is the best disinfectant you can possibly use.
Yeah, and would I be right in saying that there'd be no supplier as such we would recommend, or no brand we would recommend?
I think to be wrong for me to say go to BioCell and use Rockwort, which is a quaternary ammonium compound. What I am saying is, develop a relationship with your chemical supplier. Sit down and talk to them about the product you're producing and about the soil and debris that you want to remove. And after removal, about rinsing and then using a disinfectant.
And if they work with companies or supply companies that are producing similar type food products or similar,
yeah.
They might be in a better position to advise.
Absolutely, yeah.
Obviously, they'll be competitive in terms of cost, and then location, depending on whether it's delivery, how quick.
And again, as well, what should be remembered is, if you're a very small company, you can buy these things in 25-litre drums. You don't have to buy them in a 200-litre or in a 1,000-litre IBC. So they are available in small quantities.
And again, it will depend on the supplier and what quantities they're willing to supply.
Yeah.
So ask around, make a few phone
Indeed.
calls and determine it that way. But building the relationship, as you say, is the key.
It's very, very important. Yeah.
And then you can go to them with future needs as and when they arise. So what do food businesses need to consider in relation to their specific food products or facility? So are there specific things at the outset?
Foods are extremely complex. They contain lots of products. I mentioned fats, sugars, proteins, salts, and so forth. Other organic materials that are difficult to remove from surfaces and food production plants. But you need to understand the role of what your cleaning chemicals are doing, right? And again, I bring it back to the very, very last slide. And the very last slide is about videos produced in conjunction with MTL and SafeFood. And they go a long way to helping you in terms of making a choice and the type of cleaning that you need. But it's about tying your cleaning regime into the product that you're actually producing.
And there's a specific question here around the use of peracetic acid. So is it useful to use peracetic acid in a CIP system for a pasteurizer, or is a detergent wash and acid enough?
Detergent wash and acid are commonly used. But remember, peracetic acid is an acid, right? Is an acid. So I would use a detergent wash. I would possibly, though again, depending on the product you're using, right? I would use peracetic acid as a terminal disinfectant as well. At a very, very low level, you're talking about only, 25 parts per million, something like that.
Okay, thanks, Eddie. And I'm just conscious.
And at a low temperature.
Okay. So another question with regards to what are our legal obligations as a food company? So what are we actually required to do?
Oh, this is a difficult one and a straightforward one at the same time. The law is very clear, Ciara. Every person working in a food handling area must maintain a high degree of personal cleanliness and is obliged to wear suitable and clean protective clothing. And the clothing then is designed to keep you away from the food product. It's not designed to keep your nice shirt clean and your nice tie clean and so forth, right? No person suffering or being a carrier of a disease. If you have, God forbid, if you have diarrhea or something, you're supposed to notify the manager, the officer in charge, whomever it is, and not turn up for work. Again, infected wounds, skin infections, sores and so forth. And you shouldn't be permitted to handle or work in a food area unless there's protection in there and so forth. And EU law clearly states, that the principal objective of the hygiene rules and regulations is to ensure a high level of consumer protection with regard to food safety. And that's what the rules are all about. It's about producing safe food. And this requires a wholly integrated approach, right? From the primary place of production, the factory, up to including placing the food on the market shelf. And every food business operator along the chain has a responsibility to ensure that this is done properly. So whether you're a supplier of primary ingredients, whether you're actually a processor on site, and so forth, we all have responsibility as an FBO with regard to food safety and producing food in a safe manner. Okay?
Thanks, Eddie. And there's just one question, I hope a short one, that's come in here at the end. Is sanitation as effective as disinfection?
A very good question. A very good question. Some people use chlorinated detergents, and they are very, very good. They really are, right? Personally, I would prefer to use a detergent with surfactants to remove my soil, then rinse, and then use a disinfectant. I think you are much clearer and you get a much better kill rate of the microorganisms as well.
Okay. I think we're going to have to wrap it up at this point. So I'd like to thank Eddie for his time. I would thank you all for attending and for contributing to the Q&A session, and for your attention throughout. And we hope you'll join us for the next webinar. Bye for now.